Alrighty then. Did you have a chance to work this out? Doesn't sound too happy, huh? Solution. So, anybody like to tell me what do they guess for A? Yes?
So I got a half times 1 minus 3x.
1/2 times 1 minus 3x
To the negative 1.
to the negative 1/2. Right?
Yes, I guess.
That's what you got.
That's my guess.
Fine. How many of you guessed the same thing? 1, 2, 3, 4, 5, 6. 6 people. Anyone likes to give me a different answer? Yes?
Well, I multiplied each term by, or to the 1/2 power. So I did, you want me to give you my final answer or tell you what?
No, tell you what you did. Tell me what you did.
So I did 1 to the 1/2 minus 3x to the 1/2.
Okay, I see.
And then I applied the power rule.
So one thing, okay, let me just tell. So this is solution 1. And solution 2 is we have 1 minus 3x to the power of 1/2. And then you say, what you first do is you say equal to 1 to the power of 1/2 minus
3x to the power of 1/2.
Okay.
And then I applied the
Okay.
power rule.
Okay. And then take derivative. This is solution 2. So, all right. Thank you. Now let me tell you about solution number 1. Is it right or wrong? It is wrong. Sorry, I didn't mean to be too judgmental. I just hope that that you will develop the right instincts for it. It is wrong. Now solution number 2. Right or wrong? Can you do this? Oh, this is a no, right? This is wrong. You don't distribute the 1/2. You see, a common algebraic mistake is to do this. This is no. No, you see, think about how power works. It does not distribute. Powers don't distribute through addition. You can think of a simpler example. 1/2, I mean, we can actually, I can show you why 1/2 doesn't distribute, but if you have a plus b, or let's even give it numbers. If you have 1 plus 2, right? And let's say you square it. If you don't distribute, this is just the same as 3 squared, which is 9, correct? But if you do this process, what do you get? You get 1 squared plus 2 squared, which is 5. And you can see that this is not equal. I mean, this is actually equal, but this one is not equal. Okay? The same will work through 1/2. Okay? You can make many, many mistakes, billions of them, impossible to correct you, if you do not think about what you're doing. If you use something and you don't understand why it works, you will make mistakes, I guarantee it. That's why people fail. You try to find shortcuts. You can use shortcuts only if you understand why they work. If you use them and you don't understand why they work, you will get wrong answers. 1, 2, incorrect. All right, now let's look at B. Let's use the definition of the derivative and find what's the right answer. So f prime of x will be equal, I like this limit much more and use it more often, limit as z goes to x of f of z minus f of x over z minus x. There is nothing wrong with using the other definition. It just will involve more writing, more symbols to put in on paper, and therefore harder to look at. Now what is this? This is limit as z goes to x of root 1 minus 3z minus root 1 minus 3x over z minus x, correct? What is this? Now, what do you do here? You stare at it, what do you do with it? Don't be scared. It's okay.
Would you combine 3z and 3x?
How do I combine them?
Like first you change it to 1/2. Like I don't like the.
Okay, you don't like this? Sure, so let's change it to 1/2. Why not? By the way, you should ask yourself, why is root equal to 1/2? That's one question nobody bothered asking here. Why do you use 1/2? Why is root 1/2? Why is cube root 1/3? Why is that? Ask a lot of questions. Go crazy. Did you see the videos?
Yeah.
Watch the videos for inspiration. All right. We did this. What now?
I remember you combined like the like terms.
How?
Like 3z.
Okay. How do I combine like terms? Don't remember what I do. It should come from your heart, not what I do.
Would it be minus 3z plus 3x to the 1/2? And then
Again, you use the same thing. 1/2 don't distribute. So if they are here, you use it in reverse, right? So one way is to go from here to here. Another way is to go from here to here. Both ways are impossible.
Distribute the negative number. I'm sorry, no, that's wrong. Since both expressions have negative 1 over 2, shouldn't we combine them because they're under?
How do we combine them?
It's a good question.
It's a good question, yes.
Can we square it?
If we square it, we change the expression. A number and a number squared is a different expression. No.
Just combine.
This is, if you have one thing minus another, under the root, why not try multiplying by the conjugate? Right?
Yeah.
Again, actually, why it works for the same reason that it's really, again, another instance of factoring and powers. It just doesn't look to you like it yet. So what you do is, you multiply by the conjugate. So here I write z minus x. Here I write, what is the conjugate? The conjugate, I prefer to write roots, so I write 1 minus 3z, close root, what's the symbol here? Plus root 1 minus 3x. And if I multiply the conjugate, I get 1 minus 3z minus 1 minus 3x. You understood what I did? I just look here. This is a minus b. I multiplied by a plus b. So I get this expression squared minus this expression squared. Correct? Now the next step is now I can combine like terms. 1 minus 1 crosses out. 3z minus 3x. It will be actually minus 3 z minus x after I combine terms, right? 1 cancels, minus 3z plus 3x. I can write it as minus 3 factored, z minus x. And here I have z minus x, root 1 minus 3z, plus root 1 minus 3x. What do I do now? Cross out, wonderful. Now we cross this out. So that is minus 3 root 1 minus 3z plus root 1 minus 3x. What happens now?
Plug in X.
Yeah, now you push z to x. There is no problem. And what you get is minus 3. Now this expression becomes root of 1 minus 3x plus root of 1 minus 3x. So that becomes 2 root of 1 minus 3x. And to compare, what is this in terms of one of the notations? This will be minus 3 multiplied by 1 minus 3x to the power of minus 1/2 divided by 2. So it's actually similar to answer A, except it's missing a minus 3 here. Okay? But the important premise here is that if you're going to use things, if you're going to use shortcuts, why do this stuff? If you're going to use shortcuts, first thing is you're going to make mistakes if you don't understand why it works. Second thing is you will never be able to use this for anything interesting. Okay?
How did you know to do, like, when you multiply it by, you did root of 1 minus 3z plus root of 1 minus 3x?
Why did I know to multiply by the conjugate?
Is the conjugate always the opposite sign? Like
No, the conjugate of the cube root would not be the opposite sign. It's just usually people are not tortured by it. But that's a very wonderful question. So suppose that instead of this, suppose you had the cube root of, let me actually simplify it. Suppose you had the cube root of z minus the cube root of x, right? Divided by z minus x. I just don't want to write the 1 minus 3, right? Suppose you had the cube roots. What would be the conjugate in that case? Any ideas? What do you multiply it by? You want it to be z minus x, correct? So you can make it you can make it z minus x
You did minus X, so it's
as long as what's on the bottom is z minus x, and what you multiply the numerator by, and therefore the denominator by, was well, let's see, it was the cube root of z squared plus 2 cube root z, plus cube root z cube root x plus the cube root of x squared. That would have been the conjugate. Okay? It is not simple. Now, what makes it work as a conjugate? What are you really doing? There is another way of saying why this is the conjugate. Will you mind if I erase this? And I'll show you why this had to be the conjugate. Look at it. I allowed you, I said, okay, not to torture you. We know that the derivative of x to the power of 1/3 is going to be 1/3 x to the power of 1/3 minus 1. Now, how would I know that from just taking limits? You see, this is a little hard to factor. So then you wonder, I don't know how to factor this. I might as well factor the denominator. So what I can write this as is cube root of z minus the cube root of x divided by, the denominator is actually a difference of cubes if you look at it the right way. Now, how do you look at it the right way? You say this is the cube root of z cubed minus the cube root of x cubed. Do you see what I did? I did not, instead of trying to factor the numerator, I decided to factor the difference of cube in the denominator, which I can, if I'm just a little careful, I can notice it. I can see it's a difference of cubes. And that's what the conjugate is doing. It's really just doing the same thing. It just So that would be the cube root minus the cube root of x divided by the cube root of z minus the cube root of x times the cube factor. So times the first expression squared plus the first expression times the second expression plus the final expression squared. You see? Again, a difference of n powers. This is a hint for your extra credit. That's what you have to notice. You see? So this was what I multiplied by. See? This is that conjugate. You see, if you look at it, if you look at the conjugate in this case, z minus x, or z to the root of z minus root of x over z minus x. What you do? Why do you know the conjugate is root of z plus root of x? Because this is root of z minus root of x divided by root of z minus root of x root of z plus root of x. You see? That's where you know that it's the conjugate. It's really factoring squares. If it's cube root, it's factoring cubes really. Okay? Good? Now, let me give you a warning. A question like that may well be on your exam, and you'll have to do it by definition. To show me that you know algebra, to show me that you understand how this process works. Yep?
Can you explain again why is that z goes to x? Why would you pick c? I mean,
Well, you can pick anything you want. There is something that will disappear at the end. So this is a dummy variable, right? When you compute derivatives, what are you calculating? Remind me. If I calculate f prime of x, what am I calculating?
the tangent line.
The slope of the tangent line. I'm basically imagining this graph, and I'm zooming in at the point x, and I'm imagining what's going to be the slope of the local linearization of the graph. The tangent line is like also saying, if you look at a curve, look at this section, it looks like a segment of a line. That's the tangent line. Okay? So what am I doing? Why is it a tangent line? I pick 2 points. One point is fixed at x. The other point is becoming x. So the other point is z, comma f of z. It can be u, comma f of u. It doesn't matter. It's going to be something else. It's that thing that is becoming x. X is regarded as a number. So x is 1, x is 2, x is 3. Right? I just want to solve it for all possible places where I would like to zoom in and find the slope of the tangent line. That's what happens here. At our first lectures, we used x approaches a. But we just decided we want to keep the same variable x. So then we had to create a new variable. I hope it answers a little bit.
Just real quick, where is right there to the power of 1/2?
Right.
Multiplying by the conjugate.
Yep.
Got rid of that 1/2.
Multiplying by the conjugate, get rid of the 1/2. Absolutely. That's what the conjugate is. The conjugate is realizing that you have an incomplete difference of squares. So when you multiply it by this by root of 1 minus 3z plus root of 1 minus 3x, you multiply it by what is missing to make it a difference of cubes. Oh, sorry, of squares. Correct? So what happened here is it was root of the number squared minus root of the number squared, and you got rid of them. Okay? We can go on, right? Wonderful. You're preparing for the test. It's time to practice the exam, by the way. It's time to really, really start practicing. You see, even if you have some understanding of what we're doing, the algebra and then trigonometry can really do you in. Can really be bad.